Hello there. On behalf of the Brosis Foundation, it gives me great pleasure to welcome you to another Learning Together session in math. We have had quite a few sessions already, both in math and English, and it is always a joy and a privilege for us to have this opportunity to expose you to some things or just to remind you of some things that you might have seen in the past. Today, our topic will focus on circles. So we'll talk about the circumference of a circle, we'll talk about the area of a circle, and we'll talk about equations of circles. Okay, so those are the three things we hope to accomplish. Within circumference and area, there are two sub-segments that I might touch depending on how the timing works. So again, we're appreciative of the time that you're spending with us, and go tell a friend of what the Brosis Foundation is doing. We're offering these Learning Together sessions to help our students who might need additional resources. And this is students all over the world, all over the world. So tell anyone you know to go onto the Brosis Foundation webpage, and they'll be able to access some of these sessions. So let's get started. Pretend that's a circle, okay? So from the center of the circle, we have what is called the radius. It's a distance from the center to the edge or to the circumference of the circle. See the word circumference? And very interesting thing to note, if you did double the radius, it is called the diameter. Twice the radius, that is from one end to the other, passing through the center, is called the diameter. So I could make a note here. Diameter is equal to 2 times the radius. But if I give you the diameter, you can automatically determine the radius. And if I give you the radius, you can automatically determine the diameter. Beautiful. Okay, well, sometimes you might want to know what is the total distance around the circle. For example, you have a skating ring, and you want to know what would it cost to put a fence around the ring, or to put some border around the ring. You want to know how much you will need, what length you would need in order to complete the perimeter of that circle. So it's important for us to be able to calculate, not measure, but calculate the distance around the circle, which we call the circumference, based on what the radius is. And this now takes us into the formula for the circumference of a circle. So circumference, we normally use the letter C to denote circumference, or the distance around the edge of a circle. It is 2 pi r, where pi is a constant that is approximately equal to 3.142. You will also see it in some places as 22/7. It's approximately 22/7. It's approximately, you'll see people using it as approximately 3.14, and a little bit more accurate would be 3.142. As a matter of fact, many calculators will have a button on it that is pi, which gives you, it's an irrational number. That's why 22/7 is not exact, but it is a number that keeps going on and on. So pi is one of those numbers right here. Good. So if you knew the radius, you could calculate the circumference. Example, find of a circular field if radius is 40 meters. So the radius is 40 meters. What is the distance around that field? So C is equal to 2 times pi times R is equal to 2 times pi times 40 meters. You take your calculator and you go, so that's 80 times pi, so it's 80 times, and I have a pi button on my calculator, and I end up with approximately 251.3. It's approximately 251.3. There it is, circumference. So all we have to do is to properly use the formula. Plug in the radius, use pi. If you don't have a pi button, you can approximate it to pi is approximately 3.142, approximately. Okay? And that will give you your answer for pi. Now, sometimes you might want to know what is a portion of the circumference. That is not the entire circumference, but you're interested in only a part of it. So let me give an illustration for that. Okay, suppose your school has a circular stadium and the seating is in a circle like this around the stadium, and you have reserved this portion for your visitors. And then of course, this is for your home spectators. And this is for your visitors. And you want to know, what is the total distance set aside for your guests, for your visitors? Well, do you agree that the bigger this angle is, the bigger this length will be, and this is called the arc length. We call this ARC, arc length. So it's a portion of your circumference, not the entire circle, but a portion of the circumference. It's an arc. And because this is one part and this could be another part, we refer to the smaller portion as the minor arc as compared to the major arc. So the minor would be the smaller one, makes sense. The major would be the other portion. So both of them together, the minor plus the major, makes the circumference. Okay, good? So the question is, what would be the distance, what would be this arc length? And the answer is, the arc length would be equal to the length of the entire circumference times the angle here at the center over the total angle for the circle. And the total angle for the circle is 360 degrees. So if this was, say, 50, suppose this was, say, 100 degrees, then it will be 2 pi r times 100 over 360. And that will give you a portion of the circumference that is set aside for your guests, for your visitors. And that's called the arc length. And all you have to do is plug in your numbers, plug in for your angle, plug in for your radius, and that gives you the length. Okay? So, let's do an example. So this circle has a radius of 20 centimeters and the angle is 85 degrees. And the question is, find the minor arc length. Okay, so let's call this L. So L is equal to 2 pi times R times theta over 360. So this is equal to 2 times pi times R, which is 20 centimeters, times 85 over 360. And all we have to do is, because this is degree over degree, the units will cancel, okay? So it is 40 times pi times 85 over 360. Well, 40 goes into that 9, so it is actually 85 divided by 9. 85 divided by 9 happens to be 85 divided by 9 happens to be, wow, approximately 9.44 centimeters. Yep, so that will be your answer for that. So now we are finished with the circumference. Notice, if it was another shape, you would say it's the perimeter, it's the distance around the edge. But for circles, we refer to the perimeter as circumference. They are synonymous, okay? They have the same meaning. Okay, so now let's transition over into the area. Okay. Okay, so suppose you have a play area or, a play area for the kids, and it's in the form of a circle. And you say, okay, you don't want the kids to fall and hurt themselves, so you're gonna make it be a grassy area, not concrete, but grass. And you want to know what area is that circle covering? Well, the area is going to be equal to pi. Of course, it's going to depend. The bigger the radius, the bigger the area. Small radius, small area. Large radius, large area. So it's always dependent on the radius. It's going to be pi r squared. So what is it? Whatever the radius is, multiply it by itself, and then multiply it by pi. Example. Okay, so a circular play area has a radius of 15 meters. What is the total area covered? Okay, so, I mean, an example you could have is a circular reception area, okay, or the dance floor in a ball is circular. How much carpet is needed to cover that circle? Stuff like that. So the area is equal to pi times r squared. In this case, it's going to be pi times 15 meters squared. So notice is meters squared. So it's meters times meters, 15 times 15. 15 times 15 is 225. So it's going to be 225 times pi, and that's approximately 706.85 meters squared. So that will be the total area covered. Okay? And that's that. Okay. Let's try another example. Let's try another example right now. Okay. Okay, my neighbor has a circular vegetable garden, and he decided, this is just make believe, and he decided that this portion of his garden, where this is about, yes, which is about 78 degrees, is planted using, let's use tomatoes. Using tomatoes, okay? Plastic, well, to be precise. Okay? So the question is, what area of the garden is covered by tomatoes? Well, if the radius of the garden is say, let's use, again, 20 meters, then the shaded area is going to be equal to pi r squared, which will be the area of the entire circle, times the portion of the circle covered by that section right there. And this is called a sector. So when we're talking about a piece of the outside here, we say this is an arc. When we talk about a portion like this, a pizza slice, okay, or a piece of cake, then we say that that's a sector. That shape is a sector, okay? So in this case, it's going to be pi times 20 meters squared times, and in this case, we have 78 over 360. 78 degrees over 360 degrees. Okay? And then all we have to do is to get our calculator and let our calculator do all this work for us. And let's see what we end up with. So 20 squared is 400. Okay? Times 78 divided by 360 and multiplied by pi. And that works out to be, okay, 272.27. That's 272.27 square meters or meters squared. So this portion of the circle is only 272.27 meters squared, okay? Which is different from the area of the entire circle. So now we have dealt with the circumference, we have dealt with arc length, and we have also dealt with area of a circle, and we have also dealt with the area of a sector, which is a slice of the pie, okay? So now we need to transition over into the third concept, which now involves a little higher processing. So we started off with something small, as in the circumference, then the area, And now we're going to transition over into the equation of the circle. When we're talking about the area of the equation of a circle, we're looking for a way, a formula to represent the circle if you were to have it on a graph. Keep that in mind, a graph. And a graph, of course, is a two-dimensional plane. So it's a two-dimensional X and Y axes. Okay? So keep this in mind. When you draw the axes, you will have two types of circles. One in which the center of the circle is at the origin, that is where the X and the Y axes meet. This is X and this is Y. Or two is where the center is elsewhere in the coordinate plane. So we're talking about having something like this. Don't judge me. I'm going to sketch it. Okay, so that's one version, assuming that the center is at the origin. And another version could be where the center is somewhere in the coordinate plane, whether in the first quadrant, the second, the third, the fourth, or somewhere in between. Okay, it could be on the axes. So these are the two situations we have. One, when the center is at the origin, where the two axes intersect, or the center is somewhere else on your graph. Okay? So we're going to deal with, that's why we have equations, because there are two different approaches. So we're going to explain the one that is here, which is the easier version, and then we talk about the one that is here, which is a little bit more involved. Okay? So stay with me, and here we go. This is number one, circle with center at the origin. And that is, of course, the point 0, 0. Okay, so here we go. Okay, so if this is the center, any line from the center to the perimeter or to the edge of the circle is called the radius, R. Any line, it doesn't matter what direction, it will be the same length, R. Okay? From the center to the edge of the circle, will be a radius R. Now, let's picture P as any point on your circle, any point on the circle, on the perimeter or on the circumference. Notice I keep saying perimeter, circumference, because they are interchangeable. It's just that when you're dealing with a circle, then we talk about circumference. We qualify it even further. But all it's doing is just measuring the distance around the circle. Okay, so the question is, what is the relationship between R and the values X and Y? Is there a relationship? And the answer is yes, there's a relationship. Watch this. This point XY means that if I drop a perpendicular here, it forms a right angle. So this distance right here, according to how you read a point on a graph, the x means x along the x-axis. So you go to the right x, and in this case you go up y units. So the horizontal is x, the vertical is y, and the hypotenuse is r. And the Pythagorean theorem is a way to connect the three sides of your right triangle. What does it say? It says that this squared plus that squared is equal to the hypotenuse squared. X squared plus y squared is always equal to r squared. Guess what? This is the equation of your circle whose center is at the origin and whose radius is r. So that's the equation of your circle. If the center is at the origin and the radius is r, that's the equation, and it will always work. Okay, let's do an example. Find the radius of a circle with equation x squared plus y squared minus 7 equal to 29. X squared plus y squared minus 7 is equal to 29. What is the radius of that circle? Well, the way you answer a question like that is to take the equation you're given and see if it matches the template. See if you could get it looking like this. And when you do that, you'll be able to identify the radius. So, how do we proceed? Let me get some space over here. Okay. We have x squared plus y squared minus 7 equal to 29. We would like to rewrite it so that the x and the y are by themselves on the left side and the constants are put to the right. So we need to get rid of the negative 7. So we end up with x squared plus y squared is equal to 36. Now this looks good. X squared plus y squared equal to something. So this has to be your r squared. So if this is r squared, what is r? R must be the square root of 36, which is equal to 6. R squared equal to 36. So therefore, the radius equal to the square root of 36, which is 6. And that's your radius. Okay? Let's try another one. Find the radius of a circle with equation Okay, so 2y squared minus 8 plus x squared equal to 6 plus y squared. What is the radius of that circle? Okay, let me write here so we have space to work with, and let's see what happens. Well, we have 2y squared minus 8 plus x squared equal to 6 plus y squared. And we know that the equation of a circle looks like this if the center is at the origin. So we don't know anything else yet. So you would assume that the question that I asked you must be related to what we know. Yes, it is. So let's go. Let's see if we could tweak this, if we could manipulate it so that it will end up looking like that. And then we can draw our conclusion. Okay, let's go. Let's see if we could get all the x's and the y's on the left side. And then get all the constants over to the right. So we would have 2y squared plus x squared. Bring this over, so yeah, minus y squared equal to 6 plus 8. What did I do? We have a minus 8 here, so I add 8 to both sides. I have a positive y squared, so I subtract y squared from both sides. And now, 2y squared, take away y squared, gives you just y squared plus x squared equal to 14. Now this looks good. So y squared plus x squared equal to 14, of course, is the same thing as x squared plus y squared. The two are interchangeable. I can switch them around. For example, 10 plus 3 is 13. 3 plus 10 is 13. The order doesn't matter. It's the same result. That's called commutative. What is the word? The word is C-O-M-M-U-T-A-T-I-V-E. It's the commutative property of addition. Okay, meaning that the order is not important because A plus B is the same as B plus A. That's what it means. Okay. So the x squared and the y squared are fine. 14 represents r squared. So I can write r squared equal to 14. So therefore, r is equal to the square root of 14. And guess what? The square root of 14 is an irrational number, meaning that you will not get an integer or an whole number. So you could just leave it as the square root of 14 because whatever you write will not be an exact answer. It will be an approximation. But if you leave it as the square root of 14, then it's perfect. Okay? What is the answer going to be approximately equal to? Well, 3 squared is 9, 4 squared is 16. So it's somewhere between 3 and 4. So I would guess maybe about 3.75. I don't know. But square root of 14 is great. Okay? Good. Let's go now to the next type of circle, the one that has a center that is not at the origin. So the center could be somewhere else in the coordinate plane. Let's see what happens. Number 2. Circle with center, not. So notice now, it's not at the origin. Let's emphasize. Okay? So, here we go. I'm just going to use this as an example, and it will work for anywhere you put the circle, as long as the center is not here. So, let's say the center And let's call that okay. So let the center be A, comma B. Okay? This is your radius. From the center to the circumference is your radius. Okay? From the center to any point on your circle is your radius. So this is your center AB, and this is any point XY on your circle. So this is how we do it. Let's drop a perpendicular here. Let's drop a perpendicular here. Let's do a horizontal line here. Let's do a horizontal line here. Okay, so let's reason. From here, the origin to here is your X value, so that's A. And from here to here, that's your X. Let's move this across right here. So we're forming a right triangle right in the space right here. So look at this. From here to here is B. From here to here is Y. So truthfully, this distance from here to here has to be the difference between Y and B. So it is Y take away B. That's what this distance is going to be. And of course, this distance is going to be the same as this distance. So these two lines are parallel. So this is the same. Now, from here to here is A. From here to here is X. So this distance has to be X minus A. And of course, it's going to be the same as this portion right here, X minus A. So this is X minus A. This is Y minus B. So remember the rule, if you have a right triangle, then when you square the leg and square the other leg and add them, that will be equal to the hypotenuse squared. So the sum of the square of the legs is equal to the hypotenuse squared. So how do you represent that in the form of an equation? Well, what is this leg? It's X minus A. So let's square it. So X minus A squared. So that is this side of your right angle. This is the other side, it's Y minus B. That has to be equal to the radius squared. So here we come now. This is the equation of a circle whose center is at AB, the point AB, and whose radius is equal to R. Because this is abstract, it looks more involved and more complicated. So what we're going to do is, we're going to do an example that involves numbers, and you will see that it makes a lot more sense. So we're going to go to a question that involves numbers. So I hope you're making notes, but I prefer to give you a reasoning so you see where the result comes from, rather than just give you the equation. Notice what we're using here again is the Pythagorean theorem. That's what we're using. A squared plus B squared equal to C squared. That's how most people remember the Pythagorean theorem. That's how you connect the three sides of a right triangle by squaring the legs, add them, squaring the hypotenuse, and putting the sum of the legs equal to the hypotenuse squared. Okay, let's go to some examples now. Okay, write the equation of a circle with radius of 7 and center at the point 3, 5. Okay, so what is the formula? The formula says x minus the x value at the center squared plus y minus the y value at the center squared is equal to r squared. So x minus, what is the x value at the center? It's 3. And you square it plus y minus, what is the y value at the center? It's 5. Equal to r squared. What is r? R is 7. What is r squared? And that would be the answer to the question. How cool is that? Once you know and understand the relationship between the radius and the center, you can write the equation. Let's try another example. Okay, I just try to be a little slick. You know, sometimes I try to trick you, see if you're paying attention. So, write the equation of a circle with center at the point -2, 4 and diameter of 10. Wait a minute. Whoa, I thought we need the radius. We don't have the radius. Well, technically, we do, because I gave you the diameter, and there's a relationship between the diameter and the radius. Do you remember what it is? I. Great job. the diameter is double the radius. So if the diameter is 10, the radius must be 5. Super. So let's go. The equation is going to be x minus the x value, which is -2 squared, plus y minus the y value, which is 4, squared, is equal to the radius squared. And we simplify this if possible. Well, x minus -2 is actually x plus 2 squared plus y minus 4 squared equals to 25. And that would be the equation of the circle. Is that cool? I think that's very cool. What did we do? We took the diameter, and from the diameter, we determined what the radius was. The diameter is 2r, so the radius has to be 5. The center is -4, 4. So therefore, when we have x minus a, so it's x minus a negative number, gives you a positive. Y minus 4 doesn't change, so it stays right there. And you really don't have to expand this. You can just leave it just like that. Because when you leave it in this format, you can actually read off the center and the radius. So that's a nice way to put it. So what I'm going to do now is I'm going to write a few equations of circles and ask for the radius and also for the center. Find the center and radius of the given circle. So here we go. X squared minus 8. Oops, I lied. X minus 8 squared plus y minus 1 squared equal to 16. What is the center? Well, the center is, this is the x value, this is the y value, and the radius is equal to the square root of 16, and you really need the positive square root, so the answer is 4. So that's what you do for that question. So once you know the template, once you know what the equation is supposed to look like, you can extract the center and also the radius. Let's do another one. I think I could write another one here. Let's go. Okay. Y plus 3 squared. You know what? So that is not as crowded. Let me put it up here. It looks a little crowded right now. Y plus 3 squared plus x squared equal to 64. Okay, well, first thing first, we have it with the y portion first and the x portion second. So let's flip it around. So x squared plus y plus 3 squared equal to 64. Now, the fact that we have a number inside here tells me that the center is not at the origin. Because if it was at the origin, you would have x squared plus y squared equal to a number. But this is not x squared plus y squared. This is x squared plus y plus 3 in parentheses squared. So that's a different situation. So let me try and see what would I do to the x so that it's of this format. Then if I do x minus 0 squared, do you agree that x minus 0 is the same as x? So truthfully, this is just x squared. I didn't have to write the 0. But once I realize that there's a 0 here, I know that the center can be written as 0, comma. This should have been y minus the y value that goes from the center. But since I have a plus here, it tells me that my y value at the center is -3. That's how I end up with a plus. And then finally, the radius is equal to the square root of 64, which is 8. I hope you saw what just happened just now. I did two things. One, I didn't give you the x coordinate for the center. And for the y portion, there is a plus. So it's for you to realize that in order for you to have a plus here, the value for the y must have been negative. Because the format says x minus a squared plus in parentheses y minus b squared is equal to r squared. So that's what that is. Let's look at another example. Find the center and radius of a given circle. Okay, so let's look at this here. You're told that the circle has diameter as a line segment AB, that is from A to B, where A is the point 25 and B is the point 85. So if I had my graph, it would look something like this. 2, 8, 5. So this is 2, 5, and this is 8, 5. So this is your diameter. So therefore your circle has to be something like that. This is your A, this is your B. So your center is halfway between these two. So from 2 to 8 is 6 units. So therefore, what is halfway between these two? This has to be the point 5. So from here, 2 to this is 3, 5 to this is 3. So that makes sense that the radius is 3. R is 3. Okay? And what is the center of the circle? The center of the circle is going to be the point 5 across and 5 up. So now we can write the equation. The equation is going to be x minus 5 squared plus y minus 5 squared equal to r 3 squared, which is 9. So what I did, instead of telling you the radius, I gave you the diameter. I gave you a diameter for the circle. And based on the diameter, you could determine the length of the diameter and divide that by 2 gives you the radius of the circle. The midpoint of the diameter is going to give you the center. How do you find the midpoint? You add the x values divided by 2. You add the y values divided by 2. Let's go. 2 plus 8, 10 divided by 2 gives you 5. 5 plus 5, 10 divided by 2 gives you 5. Let's try another one. Another one. So okay, so I gave you a diameter again. 1, -3, and 5, 7 are the endpoints of its diameter. So the center is going to be equal to the midpoint, which is 1 plus 5 divided by 2, and -3 plus 7 divided by 2. So what's that point? 1 plus 5 is 6, divided by 2 is 3. -3 plus 7 is 4, divided by 2 is 2. That's your center. So now we know the center. All we need is the radius, and we're good to go. Well, how do you find the radius? The radius is a half. The radius is a half the distance from here to here. So we said that we learned the distance formula. So let's go. The distance or the diameter is equal to the square root of the difference between the x values. So it's 5 minus 1 squared plus the difference in the the y values, which is 7 minus 3 squared. So that's equal to the square root of 5 minus 1 squared is 5 minus 1 is 4 squared is 16 plus 7 minus 3 is 7 plus 3 is 10 plus 100. So it's going to be equal to the square root of 116. So therefore the radius is a half of that. So R is equal to the square root of 116 over 2. So what is going to be the equation? The equation is going to be x minus 3 squared plus y minus 2 squared equal to the radius squared. What is the radius squared? Well, it's going to be the square root of 116 over 2 squared. Okay? And then, of course, we end up with x minus 3 squared plus y minus 2 squared equal to square the top, you get 116, square the bottom, you get 4. So it's 116 over 4. And when you divide that, what do we get? 4 into 11 goes 2 times, remainder 3, 4 into 36 goes 9. So the answer is x minus 3 squared plus y minus 2 squared equals to 29. So therefore, the center is 3, 2, and the radius is going to be the square root of 29. Well, we already have it here. This is right here. Okay? So that's that. Okay. Good. Well, we started off with something very simple, as in the circumference of a circle, 2 pi r. We worked on the arc length, then we transitioned over to the area of a circle. Then we worked on sector, the area of a sector, which is like a piece of a pie, okay, like a pizza slice. And then we transitioned over into the equation of a circle, recognizing that the circles could have a center at the origin, which is at the point 0, 0, or it could have a center anywhere else in the coordinate plane. And there are 2 different equations we ended up with. One was x squared plus y squared equal to r squared. And the next one was x minus a in parentheses squared plus y minus b in parentheses squared will always be equal to the radius squared, where a comma b is the point of the center of the circle. Well, on behalf of the Brosis Foundation, we thank you once again for tuning in to our Learning Together sessions. I trust that you would have enjoyed yourself, you would have been challenged, even for a little bit, and we look forward to having more sessions with you. So come again, check out our website, Brosis Foundation, and if you can, why don't you make a donation? It's for a worthy cause. Thank you so much, and have a great rest of the day. Thank you.